Now, continuing with the periodic properties, today I'll teach you that is how to name the compounds whose atomic number is more than 100. See, below atomic number 100 we are having the name of the compounds like sodium means natrium, we give the symbol Na. For potassium, kalium we give the symbol K. So actually these names are given by the scientist either upon their name or the name of the place from where they belongs to or something like that. Whatever it is given by the scientist. Now the confusion arises, got it? Or the confusion arised rather I should say, when several scientists came into being for the discovery of one particular element. Previously what it was happening, one particular scientist was discovering one element. So hence entire credit goes to that particular scientist only. And accordingly he named the particular element, whatever he feels like. Clear? But when several scientists came for the discovery of a particular element, several scientists means, suppose a scientist is from Russia, another is from Denmark, another is from Scotland, another is from India, or another is from let us say America. 3 or 4 scientists are included in that particular research for the discovery of a particular element. So the Indian wanted to name it in their manner, American wanted to name it in their manner, Russian wanted to name it in their manner. Alright, so the confusion arrived there only. So IUPAC decided to avoid this particular confusion. The elements whose atomic number is more than 100, it will be named according to the IUPAC system, according to the rules which will be assigned by the IUPAC system. They also decided that below 100 we will not name those particular elements because we will not disrespect the scientist. Got it? Hence they decided that above 100 the elements which are there, it will be named according to the IUPAC rules, according to the IUPAC system. Got it now? That why above 100 we are taking, why not below 100? Alright, the reason is this. Alright, fine. Now how will you name it? It's very simple, it's not so difficult. You have to remember little bit few things. Now for example, 0 it is nil, for 1 it is un, then 2 it is bi, 3 it is tri, 4 it is quad, 5 it is pent, 6 it is hex, 7 it is sept, 8 oct, 9 is n. Don't say 10, 10 means 10 only. Got it? In this way. Now why did I write this particular one? Why did I write it? The reason is that suppose an element is there whose atomic number is 105. An element is there whose atomic number is 105. How will I write this particular element? What should be the symbol of this particular element? Alright, what should be the IUPAC name of this particular element? Alright, yeah. So it is being written in this way. See here. So for 1, what I have written? Un. U-N-N. The first letter of that particular one is taken from as a symbol. Now wait. 0 is what? Nil. For 5 is what? It is pent. And the last we will be adding yum to all the names. To all the names we will be adding yum. And what I said, the first letter is taken. 1 it is U, for 0 N, and for 5 it is P. So hence the symbol you got it, U-N-P. The symbol you got it. U-N-P. In this way the symbol you got it. Alright. This was the symbol. The symbolically it was being taken. So the rule is that what you have to do is that first you have to remember this. It's quite easy, not difficult thing. Then after that you will be writing in this way. And at the last, for all the names you will be adding yum to it. Yum for the last. So hence what is the name you got it? Now you will not write in this way, un plus nil plus. Just I showed you. What you will write it? That is un nil. Here 2n is there. Altogether 3, but you can take 2 maximum. So un nil pent yum. Un nil pent yum. This is the IUPAC name of the element whose atomic number is 105. Suppose the element, if it is not discovered, let us say the element is not discovered, but the name is discovered. The symbol is discovered. Alright, the symbol is UNP. The name is un-nil pentium. Suppose you will say an element is there whose atomic number is 132. Let us see. Total of 118 is there, isn't it? Just I am saying, hypothetical case I am giving you. Let us say 132 element is discovered, let us say. But before that you can write the name. According to the IUPAC system, you can write the name. The name is written in the periodic table does not mean that the element is discovered. You might be thinking that. If you see the periodic table, you will find that all the 118 elements, his name is there. But it does not mean that all the 118 elements is discovered. Or we are knowing the properties of all the elements. No. Not at all. I have said it in the previous AV. So here what should be the name? It is un. For 3 it is tri. Alright, let me write it directly. It is tri. For 2 it is bi, and for at the last you will be adding yum. So what is untribium? It will be. What should be the symbol? The symbol will be U. Alright. First one. Then from 3 it is T. Alright. And from 2 it is bi. So UTB. We can say this is a symbol. This is a symbol. We can say that. In this way, the symbol is being given, the name is being given for the element whose atomic number is more than 100. So you have to remember this. First you need to remember, most of the things you know it. Then after that you need to write in this way. Alright, you need to write in this particular way. See, I have written it here. The 2 examples I have given you. So now you can write the name of any atomic number. Any atomic number, what you can say, you can write the name now. And you can also write the symbol at the same time. The first letter is capital, the second and third it is small. It should be the same rule what we are having it previously. Alright, fine. So in this way you came to know the how to write the IUPAC name of element whose atomic number is more than 100. Done. Now we will come to know that a particular element in the periodic table we have got 2, 8, 8, 18, 18, 32 elements are there. Alright. Now if it is asked in the exams that you what you can say justify that the third period consists of 8 elements or the fifth period consists of 18 elements, you justify it. How will you justify? How will you justify? I am justifying it now. See it for all the periods. I am justifying it now. Got my question? The question is there in a book. That justify that the fifth period consists of 18 elements. How to justify it? See it. Now see, very easy. You will make column. I am doing for all the periods. Understood? You will just do for one period, whichever it comes. Period first of all. Then number of energy level. Alright, number of energy level being filled. How many energy level is filled? First, second, third, fourth, and this way. And we will be writing it out. Then after that, subshells being filled. I have to write it small. I will not have space. Then after subshells being filled, you will be writing it out. That is nothing but number of electrons of that elements. Alright. Or number of electron of that element in a particular period. Or number of elements of that element in a particular period. Let me write it. Number of electrons E minus or elements, both I have written, in a period. In a given period, we can say that. So, fine. Now see it. Period, it is n is equal to 1, then n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, n is equal to 7. In this way we are having. Clear? That is 7 periods we got it. Now, number of energy levels is also the same thing. Suppose if you take it here 1, 2, 3, 4, 5, 6, then here it will be number of energy level means n is equal to 1. Same thing we can write it down. Same thing it is. Got it? So here you do one thing. Better is that you write it here 1, 2, 3, 4, 5, 6 and here you write it as this. Because number of energy level means n. So it will be better for you to understand. Otherwise both it is same it is. Got it? Now, fine. Now subshells being filled. Now here you have to understand. The first shell consists of how many subshell? 1s. Second shell consists of how many subshell? 2s and 2p. Yes or no? Third shell consists of 3s, 3p and 3d. We can say that. Clear? So the third shell, that is n is equal to 3s and 3p. We can say. And the fourth shell, that is 4s, 3d and 4p. In this way, 4s, 3d, 4p. It will be 5s, 4d, 5p. The fifth one, I have written it. Then sixth, it will be 6s, 4f, 5d, 6p. I don't have the space. 6s, 4f, 5d and 6p. Similarly, for the seventh, you write it down. 7s, 5f, 6d, 7p. Alright? Now you see it here. Now S subshell, maximum how many electrons? 2. So write it 2. Now here S subshell 2 and P subshell 6. So 2 plus 6 is how much? 8. The second period consists of how many elements? 8. Now third shell, again S and P. S is 2, maximum 2, P is 6. So it is 8. Now fourth you see S is 2, then D is 10 and P is 6. So it is what? 18. Same thing here also, same thing, 2 plus 10 plus 6, it is 18. Here you see it is 2 plus 14 plus 10 plus 6. Here S, F, D, P. 2 maximum electrons I am taking. 2 electrons, then 14 electrons, then 10 electrons and 6 electrons. Which you get it as 32. Got it? 14 plus 2 it is. Let me put a line here so that it will be differentiated clearly. So 14 plus 2, 16 plus 10, 26 plus 6, 32. In this way, for the seventh also you will be doing in this way, you will be getting 32 elements. Got it? Seventh, maximum 32, we can say that. Clear? So in this way, you can justify that, suppose it asks that fifth period, fifth period, you will write only this one. And you will define this 5s, 4d and 5p subshells it contains, and as a result, the number of maximum number of electrons can be 18. So hence, the fifth period contains maximum 18 elements or 18 electrons, whatever you can say that. Clear? So, in this way, we can justify it. This is very important questions I have discussed with you. Fine. After that, another very important questions. It will be asked to you that find out, suppose an element is given, atomic number is given. Got it? Atomic mass also may be given to you. Atomic number may or may not be given, mind it. You have to learn it, the atomic number up to 40. You need to learn it, the atomic number up to 40. Alright, I'll be sending you a shortcut method how to remember it up to atomic number 40, so to say. Okay? Achha. So, whatever it is. Suppose an atomic number is given, element is given, atomic number is given, and atomic mass is given. Clear? So, you will be asked to determine that in which period it belongs to, in which group it belongs to, in which block it belongs to, what is the valency, whether it is a metal, non-metal, and etc. question will be asked. But it main is your period, block and group. So how to find it out? That I am going to say you now. Alright, understood my question? An element will be given, atomic number, atomic mass will be given. You have to find it out, the period, block and group of that particular element. You need to find it out. Alright, clear? Fine. For example, let me take here, that is, let us say here, sodium I am taking, atomic number 11. Alright, or let me not write sodium, let me write here X atomic 11. I don't know what is that element X is. Because if I give sodium, you may mug it up. Alright, and you can say the answer. But I have not given you the element, I have written it as X, let us say. Now first what you need to do is that, atomic number is given means write the electronic configuration. 1s2, 2s2, 2p6, 3s1. So the highest principal quantum number gives the number of shells or number of period. So the period in which it belongs to is third period. See, the highest principal quantum number is 3. So this element belongs to third period. The highest principal quantum number determines the period. Mind it. So highest principal quantum number is 3. Now we will find a group. Then I will go to the block. So which group? I told you. The last electrons which enters into a particular subshell, that determines the group. So last electrons enters into S subshell, so it belongs to, that is, group I am saying block. That is block. First block, then group. So last electrons enters into S subshell, so it belongs to S block. We can say that. It belongs to S block, last electron. Last electron in whichever subshell is entered. Suppose it enters into P subshell, P block. If it enters into D subshell, D block. If it enters into F subshell, F block. In this way, first we find the block. Then after that, the group. So group is, if an element belongs to S block, remember it. It has only two groups. Either it can be group 1 or it can be group 2. So how do we find it out? From the valence electrons. What is the valence electron here? 1. Because this is a valence shell, na? This is outermost shell. Isn't it? The valence electron is 1. So it is group 1 in this way. If an element belongs to S block, remember it, for every block the formula is different. The finding is different. If an element belongs to S block, then it can have only 2 groups. You know it. Group 1, group 2. How will you find it out? The valence electron determines the group. The valence electron is 1. So 1. Suppose you have been here 2, then 2. Can you have 3 here? No. Because maximum capacity of S subshell is 2 only. So hence it has only 2 groups. Group 1, group 2. In this way you need to write the electronic configuration first, then find the period, then the block, and then the group. So in this way you understood for the S block. Now we'll come to the, let us say we'll come to the P block. Let us take an element, let us write the atomic number and let us find it out. Okay. Now let me take another element here, Y. Alright, whose atomic number is, what should I take it is here? That is nothing but it is 15, let us. Atomic number 15. I am giving you a smaller one. Got it? So 15. So 1 is 2, 2 is 2, 2p6, 3 is 2, 3p 3. Let us count it and see. 6, 4, 10, 2, 12 and 3, 15. Correct. So we got it. 3p 3. So what is the period in which it belongs to? That is third period, because its highest principal quantum number is 3. You can see it here, 3. So period is third period. Then after that we'll find out the block. Block is last electron enters into P block. P subshell, you can see. So it is P block. Block is P. See, the last electron enters into the P subshell. So it is P block. Then after that group. Now here the formula is. Listen carefully. 10 plus for the P block. If an element belongs to P block, then to find the group, the formula is 10 plus number of electrons in valence shell. Listen carefully here. See carefully. Number of electrons in valence shell, 10 plus. So what is the number of electrons in valence shell? It is this. This is your valence shell. This is your subshell. This is a subshell, mind it. S and P are the subshell. So this is your valence shell. In the previous case only 1 was there. So I said that is the 3s1. In the previous case it was there. So I said this is the last shell. Yes, only 1 subshell was there. But here 2 subshells are there. So 2 subshells will determine 1 shell. Yeah, because this is also 3, this is also 3. So it belongs to third shell. And it has got 2 subshells. Mind it, I have written it as shell here, not subshell. Got it? So listen carefully all of you. So hence it will be 10 plus how much? 5. So it is group 15. So 2 plus 3. See, number of electrons in valence shell. How many it is? 5 electrons is there in the valence shell. So hence it belongs to group 15. We can say that. Clear? Period third, block P and group 15 we can say. Clear? So in this way we can determine the group of the P block. 10 plus number of electrons in the valence shell. See, this I am saying repeatedly. Understand it. This is your subshell. This is your subshell. But together it is a shell. It's outermost shell, the valence shell. Clear? Now, next. If an element belongs to D block, how will you find it out? D block. For example, let us write it down here. Z25. Let us write it down here. So it will be 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, 4 is 2, 3d5. Count it and see. 6, 4, 10, 2, 12, 6, 18 to 20, 25. Fine. So we got. So what is the period here? Which period it belongs to? Highest principal quantum number C4. This is your outermost shell. Mind it, because only 1 subshell is there. This is outermost shell. See, highest principal quantum number. So period 4th. It is not necessary that the one which is written in the last, it should be the last shell. I told you this one earlier also. I have explained you. Got it? So highest principal quantum number is 4. So it is the 4th period. This is outermost shell also. Mind it. Now, next is, in which block last electrons enters into D subshells? It is D block. Which group? For the group, the formula is 2 plus n minus 1 D electrons, where n is equal to highest principal quantum number. Highest principal quantum number. 2 plus n minus 1 D electrons. Fine. So 2 plus n is here. What is the highest principal quantum number? 4. 4 minus 1 it is 3. So it is 3d electrons. In 3d how many electrons is there? 5. So hence 2 plus 5. So it is 7. Understood? Don't write 3d 5. You have to only want the number of electrons. Here what I have written, n minus 1d electron, 2 plus n. So here I want the number. You might write here 3d5. Can I add 3d5 plus 2? Got it? Have some common sense. So in this way, I want the number of electrons here. So number of electrons in 3D is how many? 5 electrons is there. Because what I have written, n minus 1. N is highest principal, but highest is what? 4. 4 minus 1 is 3D. In 3D, how many electrons is there? 5 electrons. Suppose here highest would have been 5. 5 minus 1 is 4. 4D. In 4D, you find it out how many electrons is there. How many electrons? I have written C. Electrons. N minus 1D electrons. Got it? 2 plus. So hence, it belongs to which group? It is group 7. Alright. Now, if an element belongs to F block, you write electronic configuration. If you find if the last electrons enters into the F subshell. If an element belongs to F block, I have told you earlier, it has got only one group, that is group 3. Because for that reason only, F block elements are called inert transition elements, because it lies within the transition elements. You see your periodic table, you will find it out. That F block elements belongs to group 3. So if an element belongs to F block, no need to find the group. The group is 3 for all the elements. The group is 3. You can see the periodic table properly, you will find it out. You will get the answer. Got it? So period is determined by the highest principal quantum number. Block is determined by the electrons which is entering into which particular subshell, and the group is determined accordingly, which I said you. And the valence electrons also, I have told you how it is determined. If an element has got 1, 2 or 3 valence electrons, it is a metal. If it is 4, it's a metalloid. If it has got 5, 6, 7 valence electrons, it is a non-metal. And 8, is an inert gas. You know it everything. So in this way, we can determine the group, period, block and all these things. Thank you.